In this video, I'm going to be talking about properties of logarithms. The product to sum property, the quotient to difference, and the kind of power property of logarithms. Okay, first we've got the product to sum property. And this is kind of the x squared times x to the third. And we know what to do with this. We have 2 powers of x, and then we're going to multiply in 3 more powers of x, so we will have a total of 5 powers of x. And we got that by adding the exponents. Okay. So the equivalent log property is based on the log with base x of x squared times x to the third. We know that the log is just the special exponent that we get, or that we need to put on x to get x to the 2 times x to the 3. Well, I know that I'm going to need to put that 5 exponent on this. So I know that this is going to equal 5, okay, because I put the 5 exponent on x to get x to the 5. Oh, whoops, that hurt. Now, I'm saying that what you can do is you can split this off into the 2 that the x squared is contributing, plus the 3 that the x to the third is contributing. And then we know this is kind of one of our fundamental identities, that the log base x of x to some number is just that number, right? Because it's the special exponent we put on x to get x to the 2. It's not that special. It's just 2. This is 2 plus 3 equals 5. Okay, so this is where the product to sum log property comes from. Okay, next is the quotient to difference property. Okay, so we know what to do when we have x to the 5 divided by x to the 3. There would be 5 on top and 3 on bottom, and we know how to cancel factors. So all three of those would cancel because I have more on top, and I'd be left with these additional 2. Okay, so this is x to the 5 minus 3, which is x to the 2. So the corresponding log property would be log with base of x, remember, because the base of the log relationship is the base of the exponential relationship, of x to the 5 divided by x to the 3. Okay, well, I know that this is going to need to be 2 because, I could divide those. So I'm going to expect this to come back 2. And then, well, I know that this is happening because of the 5 minus 3. So this is the log base x of x to the 5 minus log base x of x to the 3. And what special exponent do you put on x to get x to the 5? You put the 5 exponent on x to get x to the 5. And you can say the same thing about this other log. What exponent do you put on x to get x to the 3? That's the 3 exponent. Okay, so this is why these things are working. Okay, for the power property, okay, we remember what happens when we take x squared to the third power. We have x squared times x squared times x squared, which ends up with 6 total powers of x. Or we could say I multiplied the powers. So when we're talking about the log property that corresponds to this, I'm going to talk about the log with base x of x squared to the third. And maybe I ought to put something like that around it just to be sure. Okay, since I know that x squared to the third is x to the 6th, the exponent I'm going to put on x to get this expression is going to be 6. But I know that really what I did was I tripled the exponent. Okay? So what happens really, what you're going to remember, is when you see the exponent on the inside of the log, you can kind of just swing it around the front. Okay? And I'll have more evidence of this in a little bit because it goes really well with the product to sum formula. So what I have is 3 times the log base x of x squared equaling 6. Okay, but this log here, that I'm going to highlight, this is the exponent I put on x to get x squared. Well, I put the 2 exponent on x to get x squared, and I get 3 times 2 is 6. Okay, so these are the 3 main properties that we're going to be going back and forth with. Okay, so now I'm just going to write down all 3 of our log properties. We've got the product to sum, which is the log with some base. This is valid for any based log. And x and y on the inside is going to be log base b of x plus log base b of y. Okay. The quotient to difference property is log base b of x divided by y is the difference of the two logs. And then the power property is, okay, the log of, say, x to the nth power is going to be n times the log of base b of x. Okay, so we can swing that exponent around. Okay, these are the three things that you need to know. All right, so the first examples I've got for you are where they give you a log with a bunch of stuff on the inside and they tell you to do something like expand. It's like, well, why would I want to expand? There are times where it could help to use that property, okay? But we don't really have the context yet to see that. Maybe next time when we go to solve some equations, we'll see how this could be useful. Okay, so what I'm going to do is, I see that I've got x squared times y to the third, and products go to sum. So I'm going to say that's log base 2 of x squared plus log base 2 of y to the third. And then, okay, I see these exponents here and there, and I can use the property where I swing those exponents around the front. So that becomes 2 times the log with base 2 and argument x, plus 3 times the log with base 2 and argument y. Okay, and that is as expanded as it could be. All right, and then the one on the right, I'm going to say, okay, I've got multiplication here, but then division. So I'm going to need to write small also. I'm going to have the log base 3 of 9 plus the log base 3 of y to the 4 minus, I need this a little smaller, minus the log base 3 of the third root of x. Okay. Well, the log base 3 of 9, we can actually calculate that. That's the special exponent I put on 3 to get 9. That's 2. And then I can use the exponent property where I'm going to swing it around the front. But the thing is, third root of x, that's not entirely obvious. We need to remember from the last unit that the third root is the 1/3 power. And then now it's looking like something I can move around the front. So I've got 4 logs of y minus 1/3 of the log of x. And that is expanding the logarithm. The next type of thing they can ask you to do is express something as a single log. So let's get a couple of examples. All right, there we go. So the first thing on the first one, I've got a sum of 2 logs, so I can put those into 1 and multiply the arguments. Well, I know what 3 times 12 is. That's 36. Okay, and a lot of times you could just be done here. But, wait a second, I know what exponent I put on 6 to get 36. That's 2. Okay, so this one kind of came down really nicely. Not all of them are going to work like this. Like even this next one here. Maybe I'll do 2 at a time, or, to start with the first 2. Well, I've got 2 logs added together, so I can multiply their arguments. So x plus 1 times x plus 2. And then maybe I'll use the power property in reverse to kind of kick that up as an exponent. Minus the log with base 2 of x squared. Okay, now I've got 2 logs subtracted from each other, so I can divide the arguments. So this would be x plus 1 times x plus 2, and then divided by this argument over here, this x squared. That's about all you would need to know in terms of condensing logs into a single expression. Next, I've got It's the type of problem where they give you a couple of pieces of data and then they ask you to approximate logs using that. Except they're not going to give you this much. What they're going to do, okay, it's 2.4849. You might just take that and say it's about 2.4. And they might say that log of 8 is about 2.0. And they might say that log of 7 is about 1.9. And, okay, we're always allowed a scientific calculator, but on these, they're going to want a 1 decimal answer. You know, in a multiple choice, it might even be abstract. You might just say log of 12 is A, log of 8 is B, and log of 7 is C. So there's a few different ways that we can ask this question. I'll try to hit all of the different ways. But the questions that they'll ask are things that test your knowledge of the properties. Like, for instance, I would start with the natural log of 96 is approximately equal to what? Okay. Well, you have to make 96 out of 12, 8, and 7. And so you're going to have to think really far back to your times tables. 96 is 12 times 8. Okay. The ones on the quiz and test are much friendlier, right? Things like 5 times 4 is 20, or 3 times 4 is 12. You know, something like that. Okay, well, this is going to be the natural log of 12 times 8, which is equal to the natural log of 12 plus the natural log of 8, which would be 2.4 plus 2.0, which is about 4.4. Now, if you go and actually do the natural log of 96, you'll get 4.564. So on the quiz, if you give me 4.564, I'll know you just jammed it in the calculator and I won't give you any credit. Okay, so don't do that. Use the properties. You've got to use the properties. And I don't have to lie to you and give you some fake number for the log of 12. I just can round generously, and then the values don't always work out right. Okay, what if they ask you for the log of 2/3? The natural log of 2/3. It's like, well, how am I going to make 2/3 out of 12, 8, and 7? Okay, you got to think about it for a minute. And, well, if there's division in the argument, I'm probably going to have to do division between 12, 8, and 7. And you think about it for a while, and you see that 8 divided by 12 is 2/3. Okay, so that's equal to the natural log of 8 divided by 12, which is going to be the same as the log of 8 minus the log of 12. Okay, so this will be 2.0 minus 2.4, and that would be negative 0.4. Okay, you do the natural log of 2/3 in the calculator, and you get negative 0.4. Okay, so I'm not always going to lie to you. It's just risky to use the calculator. And I will be saying on the quiz, you know, show the work that leads to your answers, and the grader will be looking for that. I think the last example I've got with these particular three, natural log, would be something like the natural log of, oh, actually, I think I've got a couple more, now that I think about it. Let's do the natural log of 1/7. For sure, got to do that one. Okay, well, it's like, how do I get 7 out of 12, 8, and 7? There's two different ways you could go about this. The thing that I would think to do is say that this is 7 to the negative 1 power. And then swing that exponent around the front, so that's the negative log of 7. And so that's going to be negative 1.9. Alternatively, you could have said this is the log of 1 minus the log of 7. The log of 1 is 0 for any base, so this is 0 minus 1.9 is negative 1.9. So you see these properties, they're all just working around the same ideas. Okay? You're going to get the same thing no matter which approach you take. All right, well, what if they didn't give you a number, an actual value for these logarithms, and just said they were A and B, and they asked you to express these in terms of A and B? That's the type of question we could ask. Okay, this would make for really good multiple choice, right? So the question we might ask, you know, kind of to make it different from the other ones, would be, how about something like log base 2 of 10? Or what else could I ask? Maybe log base 2 of 1.5. Let me see if I can Oh, I've got another good one. Log base 2 of, say, I don't know, 5 to the negative 20th power. Like that. Okay, well, I'll start with the one in red. Okay, 10. How do I make 10 out of 5 and 3? You really can't. Okay, we don't have a property for the log of a sum. Okay, that's not something we do. But you can also introduce that 2, because we know what the log with base 2 and argument 2 is. That's just 1. You know, what exponent do I put on 2 to get 2? I just put the 1 exponent on 2 to get 2. And so I can use 2, 5, and 3. Okay, so I'm going to use the 2 and the 5. Okay, so this is log base 2 of 5 times 2. And then I can say that this is log base 2 of 5 plus log base 2 of 2. Okay, log base 2 of 5 is a plus, okay, what exponent do I put on 2 to get 2? That's 1. Okay, so something like that. That's something we might need to do. Cool. And you know what? I'm going to actually change this. 1.5 is far more likely to be something that you would see on a quiz or a test or something, but I'll make this one a little more difficult. Okay, I'll make this as 0.75. I like that. 0.75 is like, oh, what do I do with this? I don't have I have 3, 5, and 2. How am I going to make 75 cents? 75 cents is 3/4, 3/4. So 3 divided by 2 times 2. So what I'm going to do is I'm going to break this up into the log base 2 of 3 divided by 2 and divided by 2 again. Okay, so this is log base 2 of 3 minus the log base 2 of 4, really, right? And I guess that's something that we can do mentally. I can think of what exponent I would put on 2 to get 4. Log base 2 of 3 is equal to b, and the exponent I would put on 2 to get 4 is 2. Okay. And for the one in green, I could kind of swing that negative 20 around the front. So this is negative 20 times the log with base 2 and argument 5. Okay, they said that the log with base 2 and argument 5 was a, so this is just negative 20a. Okay, the last examples I've got for you are pretty much just backwards from the other ones. It's like, okay, so the base 10 log of a is 6, and the base 10 log of b is negative 2. And I'm just going to give you a couple of these because it's really not that different. Okay, so let's just say, we'll say, what's the log of 1 over b? What is the log of the square root of a? And what is the log of, say, maybe a divided by b? You can see this would also make a really good multiple choice type question, or a set of multiple choice questions. Okay, so log of 1 over b, that's log of b to the negative 1. But like I showed you earlier, you could do log of 1 minus log of b, and you would end up with the same thing. I'm going to use that exponent property, so negative 1 times the log of b. So negative of negative 2 is positive 2. Log of square root of a. I know that the square root is the 1/2 power. So this is half of the log base 10 in argument a. And that's going to be half of 6, which is 3. And for this one, log of a divided by b, that's our quotient to difference property. That'll be the log of a minus the log of b. And so that'll be 6 minus negative 2, which would be positive 8. And that's all I got for you in this video.